Have you ever pondered the mystery of how mountains are formed? Or perhaps wondered about the forces that shape the surface of our planet? Well, it all starts with the formation and deformation of rocks, and it's all connected to a field of study known as structural geology and tectonics. Picture a world of molten magma cooling and solidifying, giving birth to igneous rocks. Envisage a landscape where sediments accumulate and compact over time, forming layers upon layers of sedimentary rocks. Or imagine a world where existing rocks are subjected to intense heat and pressure, transforming over time into metamorphic rocks. These are the processes that give rise to the rocks that form the canvas of our planet. But rocks are not static. They change, they move, they deform. Forces such as tectonic activity, pressure, and temperature changes can cause rocks to deform in a brittle or ductile manner. Brittle deformation sees rocks fracture and break under stress, while ductile deformation results in rocks bending and flowing under the same conditions. These deformations are clues, pieces of a puzzle that reveal the geological history of an area. Now, imagine these rocks, these pieces of Earth's crust, as parts of a larger puzzle. This puzzle is known as plate tectonics. Our Earth's lithosphere is divided into several large plates moving and interacting with each other. Their movement is the driving force behind many geological processes, from the creation of mountain ranges to the occurrence of earthquakes and the formation of oceanic trenches. Consider mountains, those majestic peaks that have captured human imagination throughout history. They are the result of tectonic plates colliding, their boundaries subjected to immense pressure and deformation. This process, known as orogeny, causes the uplift and folding of the Earth's crust, creating the towering mountain ranges we see today. In conclusion, understanding the formation and deformation of rocks and the role of tectonic activity in shaping our planet is not only fascinating but also crucial. It unravels the mysteries of Earth's history and provides insights into the dynamic nature of our planet. This is the essence of structural geology and tectonics, a field that combines scientific research with a thirst for understanding the world around us. So next time you see a mountain or a rock formation, remember the incredible forces and processes that brought them into existence.
Have you ever wondered what causes the ground beneath your feet to shake during an earthquake? It's the invisible, yet powerful force of tectonics at work. Tectonics is the study of the Earth's crust and its components. Picture the Earth like an egg. The shell of the egg represents the Earth's crust, which is made up of a variety of rocks and minerals. This crust is divided into two main types: continental crust, which is less dense and thicker, and oceanic crust, which is denser and thinner. When these pieces of crust or tectonic plates move and interact with each other, it can result in geological events such as earthquakes. Now imagine a giant jigsaw puzzle, where the pieces are constantly moving, albeit very slowly. These puzzle pieces are the tectonic plates. Over time, stress builds up along the edges of these plates. When the stress becomes too great, it's released as energy, causing the ground to shake. This is what we experience as an earthquake. The study of these processes falls under the realm of structural geology, a field that uses a variety of methods to investigate the deformation and formation of rocks. This includes field mapping, where researchers document rock outcrops and geological features, and laboratory analysis, where the mineralogy, texture, and composition of rocks are studied in detail. Today, the field of structural geology and tectonics is ever evolving. One exciting area of research is the interaction between tectonic processes and climate change. Researchers are keen to understand how the movement of tectonic plates influences climate patterns and vice versa. Additionally, the advent of technology advancements like computer modeling, satellite imagery, and geophysical techniques has revolutionized the way we study our Earth. In this video, we've unpacked the relationship between earthquakes and tectonics, explored the structure of the Earth's crust, delved into the methods used in structural geology research, and touched on some of the exciting advancements in the field. For those eager to dive deeper into this fascinating world, there are many resources available, including books, research papers, and academic courses. Remember, the Earth beneath us is constantly moving and changing, and with every tremor and quake, we learn a little bit more about the dynamic world we live in.
Have you ever wondered why the Earth's landscape is so varied, with majestic mountains, vast plains, and deep ocean trenches? This diversity is not a mere chance. but the result of millions of years of geological processes, specifically those of structural geology and tectonics. Imagine the Earth as a giant puzzle, its pieces constantly shifting and evolving. These pieces, or tectonic plates, are not stationary. They move, collide, and separate, driven by the intense heat and pressure from the Earth's core. This is the essence of tectonics, the study of the Earth's lithosphere and its movement. One might liken tectonic activity to a slow, ceaseless dance. When two plates collide, they form mountain ranges like the Himalayas. When they move apart, they create spaces for oceans to form, like the Atlantic. But this dance does not end there. The plates also slide past each other, leading to earthquakes, a phenomenon we know all too well. Now, while tectonics gives us an understanding of the Earth's grand design, structural geology deals with the finer details. It examines the architecture of the Earth's crust and the ways rocks deform under stress. Think of it as the Earth's biography, each rock layer a chapter in its long history. For instance, consider the process of folding. When compressional forces act on rock layers, they bend and fold, much like a rug when pushed from its ends. This process forms intricate structures like the rolling hills of Appalachia. On the other hand, faulting occurs when rocks break due to stress. The resulting displacement creates spectacular landforms like the dramatic cliffs of the Grand Canyon. But why should we care about these geological processes? Well, understanding structural geology and tectonics allows us to predict natural disasters, locate natural resources, and even comprehend climate change. Moreover, it imbues us with a sense of wonder and respect for the Earth's complexity and dynamism. Are you intrigued by these processes that have shaped and continue to shape our planet? If so, delve deeper into the world of structural geology and tectonics. There is a wealth of resources available, from scientific journals and textbooks to online courses and forums. Engage with the scientific community, or find a mentor to guide you through this journey of discovery. Remember, every mountain, every valley, every ocean on our planet tells a story. And it is through the lens of structural geology and tectonics that we can read these stories, appreciate the Earth's beauty, and protect its future. So embark on this journey and uncover the endless wonders of our dynamic planet. It's a journey that will not only enrich your understanding, but also deepen your connection with the world around you.
My name is Ricardo Valls. I'm a professional geologist registered in the province of Ontario, Canada, and also the president of Valls Geoconsultant. Geology, geochemistry, structural analysis, machine learning, and artificial intelligence. I am sure you will find something useful among my over 400 videos.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.